Alright, so this lesson is about inscribed angles in a circle. So first we have to talk about what inscribed angles are. So if this is a circle, then the first thing we learned about was central angles. A central angle is an angle whose vertex is at the center of the circle, like this one. We would talk about the relationship between the angle measure and the measure of the arc. And for central angles, those are the same. So if this central angle is a 40-degree angle, then the measure of this arc is going to be a 40-degree arc. Okay, now let's talk about inscribed angles. So maybe I should label this. So this was a central angle. Okay, now let's compare that to an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. So it goes all the way over to the edge like this. Alright, so now let's talk about the relationship between the inscribed angle measure and the intercepted arc. And the relationship is the angle is half of the arc, or you could say the arc is double the angle. So if this was a 50-degree arc measure, then this inscribed angle would be 25 degrees. Okay, so you need to memorize this relationship. So that's an inscribed angle. Alright, so let's take a look back at an actual problem. In circle D, angle ADC has this measure. Okay, ADC. So we're talking about this angle right here has measure 7x plus 2 degrees. The arc has this measure, 8x minus 8. Okay, so the arc is right here, and that has measure 8x minus 8. What is the measure of angle ABC? Okay, so in the end, we're trying to find the measure of this angle, alright, ABC. So we're going to have to do this in two steps. First, we need to figure out what x is, and then that will tell us the measure of the blue angle, which should be the same as the pink arc. And then we'll be able to know the inscribed angle. Alright, so first of all, look at the blue angle and the red arc. Remember that for central angles, the angle and the arc are the same. So that's what's going on here. These two should be the same. Because they are the same, we can set them equal to each other. So 8x minus 8 should equal 7x plus 2, because they're the same. So we can solve this for x. So let's subtract 7x from both sides. So that'll give us x minus 8 is equal to 2. And let's add 8 to both sides. So that will give us x is equal to 10. So fine, we know what x is. Now let's substitute that back in to find out how big the angle and the arc really is. It doesn't matter which one you pick. So focus on the arc, 8x minus 8. Okay, so the arc is equal to 8x minus 8, so that's going to be 8 times 10 minus 8. So that tells us that the arc is going to be 80 minus 8. So that arc is equal to 72 degrees. Okay, so now we know that the measure of the arc is 72 degrees. Let me erase this to make space. So this is 72 degrees. So remember, what we really wanted was the green angle. All right, it says what is the measure of angle ABC? So 72 degrees is not the answer. This is an inscribed angle. So remember that the inscribed angle is half of the arc. So if the arc is 72 degrees, then the inscribed angle should be half of that, so it should be 36. So the correct answer should be 36. Kabam! All right, for the next problem, we are asked what's the measure of arc ECF? So let's see, here's arc ECF right here. So this is what we are supposed to find. So let's see what we have to work with. So notice we are given this inscribed angle right here, 79 degrees. So this inscribed angle has an intercepted arc. All right, the intercepted arc goes from here to here. So this is the intercepted arc that goes with the inscribed angle. So we're back in this situation right here. Remember that the intercepted arc should be double whatever the angle is. Okay. So if we double 79, all right, 79 times 2, we're going to get 158 degrees. So that's the measure of this arc. So look, the entire circle is really made up of only 3 arcs. We have 104 degrees over here, we have 158 degrees, and then we have the green arc that we're looking for. They all should add up to 360 degrees. So all we have to do is subtract from 360. So if we just start with 360 and subtract the other 2 arcs, so 360 minus 158 minus 104, that should give us the missing arc. Okay, so 360 minus 158 minus 104, so that's going to be 98. So the answer should be 98 degrees. Kabam! Next problem. In circle V, angle WXZ is 30 degrees. So, okay, so WXZ. So this is 30 degrees. Line segments WV and XV. Okay, they're just naming all the radii of the circle. Alright, that's obvious. What is the measure of arc WUX? Okay, we want the measure of this arc WUX. Okay. Well, let's work through this like a puzzle. So this blue angle is an inscribed angle. So the intercepted arc should be double. So if this is 30, then this is going to be 60. So with that in mind, they pointed out to us that these are radii of the circle. Okay, radii of the same circle will always be equal to each other. All right, it's a circle. It's the same distance in all directions. So that means that these triangles are equilateral triangles. Not equilateral, isosceles triangles. So this, for example, is an isosceles triangle because the sides are equal. So the base angles will also be equal. So see how this is 30 degrees? Then that means this will also be 30 degrees. Now the angles inside of a triangle always add up to 180. So here I've got 2 out of 3 angles. So all I need to do to find the third angle is subtract from 180. So since the total is 180, if I subtract the two 30s away, that's going to leave 120. So this third angle is 120 degrees. Notice that this angle is a central angle. Remember this? And the central angle and the intercepted arc should always be the same. So if this central angle is 120, that means that this intercepted arc is also 120. And that's what we were being asked to find. So the answer is going to be 120. Before we do the next problem, there's something I need you to understand. So I showed you what an inscribed angle looks like, but there are some more extreme examples that you also need to recognize as inscribed angles. So take a look at this circle. Not a very good circle, but you get the idea. If I drew an angle like this, now I'm purposefully drawing the angle going outside of the circle so you get used to that. So this is still an inscribed angle. The vertex is on the circle. Now imagine that I took this side of the angle and I moved it to make the angle wider. Alright, let's look at what that would look like. Okay, so here's my circle. Alright, so here is a very wide angle. So this angle is still an inscribed angle. Okay, now let's make it even more extreme. Alright, one more time. So here's a circle. Okay, this time I'm going to make the angle even wider. I'm going to make it so wide that this side of the angle is tangent to the circle, like this. This is still an inscribed angle. So the rule that we have for an inscribed angle is that the angle is half the measure of the intercepted arc. So that still applies. So for example, if this angle is 90 degrees, then this is the intercepted arc that goes all the way from here to here. And this should be 180 degrees. So I just need you to recognize angles like this as inscribed angles, and this would be the intercepted arc. And the relationship that the angle is half the arc still applies. So keep that in mind as we look at this problem. Okay, line EF is tangent to the circle at point A. If the measure of angle CAE is 95 degrees. So angle CAE is this angle right here, and they're telling us that this is 95 degrees. What is the measure of arc CBA? Okay, well that's going to be pretty easy because arc CBA is the intercepted arc of this inscribed angle. So it should be double this. So that should be 190. Kabam. Okay, next problem. Angle KJL is this. So let's see, KJL. So they're talking about this angle right here is angle KJL, and that is 7x minus 8. Okay, angle KML is this. So KML, that's this right here. Okay, so that's 3x plus 8. So look, these are going to be the same. Whenever you have this bow tie situation happening, okay, let me just do a rough sketch real quick. So anytime I have a circle and then I have this bow tie thing happening, like bam, 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 something like this, bow tie. The angles on the same side are going to be the same. Like this angle and this angle, they're going to be the same. So like if this is 40, then I automatically know this is 40. The angles on the other side are also going to be the same. All right, this angle and this angle are going to be the same. All right, so if this was, say, 50, then this would have to be 50. So keep that in mind. I mean, look, the reason why is because, see these two angles that are both 50? They have the same intercepted arc. All right, they both intercept the same arc. Okay, this one intercepts that arc, and this one also intercepts that arc. So let's say if this arc is 100, then the inscribed angles have to be half of this. So they both have to be half, because it's the same arc. So they both have to be 50. So that's why it happens. So anyway, we have this inscribed bow tie situation. So again, the angles that are on the same side of the bow tie are going to be the same. So that tells me that these are equal to each other. So I can set them equal to each other and solve for x. So 7x minus 8 should equal 3x plus 8. Subtract 3x from both sides. So that's going to give me 4x minus 8 is equal to 8. Add 8 to both sides. That's going to give me 4x equals 16. Divide both sides by 4. That's going to give me x equals 4. Now, what do they want to know? They want to know the measure of arc KL. So in the end, we need to know this right here. So let's go ahead and substitute 4 back into either one of these angles to figure out what the angle measure is. So I'm going to use this pink one, red, whatever. So this is, we have the 3x plus 8. If I substitute in the 4, then that's going to be 3 times 4 plus 8. So that's 12 plus 8. So that's 20. So that tells me that this angle, the red angle, is 20 degrees. So remember that the inscribed angle is half of the intercepted arc. The arc is double. So if this is 20, then the arc should be 40 degrees. So this should be the answer right here. Kabam!
Okay,
So after the more challenging problems we've already done, this problem is trivial. What's the measure of angle CAB? Well, this is an inscribed angle, so it should be half of the intercepted arc. So it should be 24 degrees. Kabam. Alright, last question. Alright, we have this paragraph proof here, and there's a blank in it, and we're supposed to say what is the missing information. Well, the blank occurs in this sentence right here, so let's just focus on this. Because of the blank theorem, the measure of angle A is equal to arc A divided by 2. Well, I guess I have to look back. This arc A is BCD. Okay, so we're really talking about arc BCD. So they're saying because of what theorem, the measure of angle A is this arc divided by 2. So this is what we've been talking about throughout the whole video. We have an inscribed angle and the intercepted arc. And we know that the angle is always going to be half of the intercepted arc. So it's just a matter of what theorem that is. So that is the inscribed angle theorem. So that should be the answer. Kabam.